For a 100 amp subpanel, the minimum grounding conductor size required by the National Electrical Code, or NEC, is number 4 American wire gauge, or AUG, copper, or number 2 AWG aluminum. Since you are using number 1 AWG copper wire for the hot leads and neutral, it is recommended to use the same size wire for the ground to maintain uniform impedance. Therefore, you should use number 1 AWG copper wire for the ground wire from the subpanel to the main panel. The wire size for the hot tub circuit should be based on the load current of the hot tub pump and other connected equipment. A typical hot tub pump draws around 50 amps when running. Assuming the other 20 amps breakers are used for low power loads, the total load current on the 100 amp subpanel will be approximately 70 amps. According to the National Electrical Code, the minimum wire size required for 70 amps load is number 6 AWG copper or number 4 AWG aluminum. However, since the subpanel breaker is rated for 100 amps, it is recommended to use wire that is rated for at least 100 amps. Therefore, you should use number 4 AWG copper wire for the hot tub circuit. All wiring should be enclosed in a metal conduit or cable tray for protection. Each circuit should be protected with an appropriate overcurrent protection device, such as a circuit breaker or fuse. The wire and overcurrent protection devices should have a short circuit current rating that is greater than or equal to the available short circuit current at the point of installation. Ensure that the subpanel is properly interconnected with the generator using an interlock kit or other approved method. The National Electrical Code, or NEC, is a comprehensive set of standards that outlines the safe installation of electrical wiring and equipment. It is updated every 3 years and is adopted by most jurisdictions in the United States. Firstly, understanding ampacity is crucial. Ampacity refers to the current in amps that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. Secondly, the NEC provides tables, such as Table 310.15b16 in the 2008 NEC, which list the ampacities of various conductors based on their size, insulation type, and insulation conditions. Factors such as ambient temperature and the number of current-carrying conductors in a raceway can affect the ampacity of a conductor, requiring adjustments or derating. For example, if you have more than 3 current-carrying conductors in a raceway, the ampacity of each conductor must be derated according to NEC Table 310.15b2. This is because the heat generated by multiple conductors can raise the overall temperature, potentially damaging the insulation and creating a fire hazard. Thirdly, grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers or fuses to operate and clear the fault. Bonding ensures that all metallic parts of an electrical system are at the same electrical potential, reducing the risk of electric shock. The size of the grounding conductor is determined by NEC Table 250.122, which is based on the size of the overcurrent protection device protecting the circuit. The grounding electrode conductor, which connects the grounding system to the earth, must be sized according to NEC Table 250.66, based on the size of the service entrance conductors. Fourthly, overcurrent protection is critical for preventing damage to electrical equipment and reducing the risk of fire. Circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a predetermined level, protecting the circuit and its components from overheating and damage. Circuit breakers are resettable, while fuses must be replaced after they blow. The overcurrent protection device must be sized appropriately for the circuit it is protecting, taking into account the ampacity of the conductors and the rating of the connected equipment. Fifthly, conduit and cable tray systems provide physical protection for electrical wiring, shielding it from damage and preventing it from coming into contact with flammable materials. Metal conduits also provide a path for grounding, ensuring that the entire electrical system is properly grounded. The type of conduit or cable tray used must be appropriate for the environment in which it is installed. For example, in wet locations, such as outdoors or in damp basements, liquid-tight flexible metal conduit or PVC conduit should be used to protect the wiring from moisture. Sixthly, when installing a subpanel, it is essential to follow the NEC guidelines for feeder conductors. Feeder conductors are the wires that supply power from the main panel to the subpanel. The size of the feeder conductors must be sufficient to carry the load served by the subpanel, and they must be protected by an overcurrent protection device at the main panel. The neutral and grounding conductors must be kept separate in the subpanel, and the subpanel must be bonded to the grounding electrode system. Seventhly, special considerations apply to hot tub circuits. Hot tubs are considered wet locations, and all wiring must be protected by a ground fault circuit interrupter, or GFCI. The GFCI is designed to detect small imbalances in current, which can indicate a ground fault, and to quickly interrupt the power to the hot tub, preventing electric shock. The hot tub circuit must also be isolated from other circuits, and it must have its own dedicated grounding electrode. Eighthly, generator connections require careful planning and execution to ensure safe and reliable operation. A transfer switch is used to switch between utility power and generator power, preventing backfeed into the utility grid. Backfeeding can be dangerous to utility workers and can damage electrical equipment. The transfer switch must be properly sized for the generator and the load it will be serving. It must also be installed in accordance with the NEC and local codes. Ninthly, short circuit current rating, or SCCR, is a critical parameter for electrical equipment. It represents the maximum fault current that a component or assembly can safely withstand without failure. Electrical equipment must have an SCCR that is equal to or greater than the available fault current at the point of installation. This ensures that the equipment will not be damaged or cause a fire in the event of a short circuit. The available fault current can be calculated using engineering methods or determined from utility data. Tenthly, voltage drop is a common problem in electrical systems, especially in long circuits. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, conductors should be sized appropriately for the load and the length of the circuit. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. 11thly, arc flash is a dangerous phenomenon that can occur when there is a fault in an electrical system. An arc flash is a release of energy in the form of heat and light, which can cause severe burns, injuries, and even death. To protect workers from arc flash hazards, employers must conduct arc flash hazard assessments and implement appropriate safety measures such as wearing personal protective equipment, or PPE, and energizing equipment before working on it. 12thly, electrical inspections are an important part of ensuring electrical safety. The electrical inspectors review electrical installations to ensure that they comply with the NEC and local codes. Inspections help to identify potential hazards and ensure that electrical systems are installed correctly and safely. It is important to obtain all necessary permits and schedule inspections before beginning any electrical work. 13thly, when working with electrical systems, it is important to follow all safety precautions. Always to energize circuits before working on them, and use appropriate personal protective equipment such as insulated gloves and safety glasses. Never work on electrical equipment when you are tired or distracted, and always follow the instructions provided by the equipment manufacturer. 14thly, continuous learning is essential for staying up to date with the latest electrical codes and technologies. The electrical industry is constantly evolving, and it is important to stay informed about new developments. Attend training courses, read industry publications, and participate in professional organizations to expand your knowledge and skills. 15thly, proper documentation is critical for electrical systems. Keep accurate records of all electrical work, including wiring diagrams, equipment specifications, and inspection reports. This documentation will be helpful for troubleshooting problems, making future modifications, and ensuring the safety of the electrical system. 16thly, when selecting electrical equipment, it is important to choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL, or Intertech, or ETL. Listing indicates that the equipment has been tested and found to comply with safety standards. Using listed equipment helps to ensure that the electrical system is safe and reliable. 17thly, proper labeling is essential for electrical systems. Label all circuits, panels, and equipment clearly and accurately. This will help to prevent confusion and ensure that the correct circuits are de-energized when performing maintenance or repairs. Use permanent markers or labels that are resistant to fading and peeling. 18thly, regular maintenance is important for electrical systems. Inspect electrical panels, wiring, and equipment regularly for signs of damage or wear. Tighten loose connections, replace worn parts, and clean up any dust or debris. Regular maintenance will help to prevent problems and extend the life of the electrical system. 19thly, energy efficiency is an important consideration for electrical systems. Use energy-efficient lighting, appliances, and equipment to reduce energy consumption and save money. Install occupancy sensors and timers to automatically turn off lights and equipment when they are not in use. Consider using renewable energy sources, such as solar panels, to generate electricity. 20thly, surge protection is important for protecting sensitive electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Install surge protectors at the service entrance and at individual outlets to protect your equipment. Following the National Electrical Code, or NEC, is of utmost importance when dealing with electrical installations. It is a comprehensive set of standards that outlines the safe installation of electrical wiring and equipment. Ignoring the NEC can lead to dangerous situations, including electric shock, fire, and equipment damage. The NEC is updated every 3 years to reflect the latest technological advancements and safety practices. It is essential to stay up to date with the latest version of the NEC and to follow its guidelines carefully. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. It provides detailed requirements for various types of electrical systems, including residential, commercial, and industrial. The NEC is adopted by most jurisdictions in the United States, and it is enforced by local electrical inspectors. It is important to obtain all necessary permits and schedule inspections before beginning any electrical work. The NEC is not a substitute for professional electrical training. It is intended to be used by qualified electricians who have the knowledge and skills to install and maintain electrical systems safely. If you are not a qualified electrician, you should hire a professional to perform any electrical work. The NEC is a living document, and it is constantly evolving to reflect the latest technological advancements and safety practices. It is important to stay informed about new developments and to adapt your electrical practices accordingly. The NEC is a valuable resource for anyone who works with electrical systems. It provides a comprehensive set of guidelines for ensuring electrical safety and preventing accidents. By following the NEC, you can help to protect yourself, your family, and your property from the dangers of electricity. The NEC is organized into chapters, articles, and sections. Each chapter covers a specific area of electrical systems, such as wiring methods or grounding. Each article covers a specific topic within a chapter, such as flexible cords and cables or grounding electrodes. Each section provides detailed requirements for specific aspects of the topic. The NEC uses a numbering system to identify each section. For example, NEC Section 300.11 covers securing and supporting wiring methods. The NEC also includes tables and figures that provide additional information and guidance. For example, NEC Table 310.15b16 provides ampacity ratings for various types of conductors. The NEC also includes annexes that provide supplementary information and guidance. The annexes are not part of the enforceable requirements of the NEC, but they can be helpful for understanding and applying the code. The NEC is available in both print and electronic formats. The electronic version allows you to search the code quickly and easily. The NEC is also available on CD-ROM and online. The NEC is a complex document, and it can be difficult to understand and apply. However, There are many resources available to help you learn about the NEC. You can attend training courses, read industry publications, and consult with experienced electricians. The NEC is a valuable tool for ensuring electrical safety. By following the NEC, you can help to protect yourself, your family, and your property from the dangers of electricity. Remember to always consult the latest edition of the National Electrical Code, or NEC, and local codes for the most accurate and up-to-date information. Always prioritize safety when working with electricity and consult with a qualified electrician if you have any doubts or concerns.